Today in pre-cal we learned about polar coordinates. And this is the third coordinate system you've learned about. The first was the rectangular or Cartesian that you started learning about in about 6th grade. Yesterday we learned about parametric coordinates, and today polar. Two definitions that you need are, the first one is that the origin is the center point. It's still in the middle here. It's a fixed point O. And it's called a pole, which is where it gets the name polar coordinate. The next word that you need is polar coordinates. And polar coordinates are r theta. So instead of x, y, it's r theta, where r represents the radius and theta represents the angle. The r is the directed distance. From O to P. And again, that's the same as the radius. And the theta is the directed angle. And we're going to use the unit circle to find that angle. Just as a quick reference point, if this takes me to my point P, O is my origin, R is my radius, and theta is my angle. And that'll happen each time you're looking at a problem like this. So you have 3 examples to look at. The first one is the point 3, negative pi over 3. And we're just trying to graph these things. So the first thing we want to do is figure out where the angle is. So the second part is negative pi over 3. This is my 0 angle. And these circles that I've given you are divided up into pi over 12. So we're going to skip the first one and move on to the second one. Would be pi over 6. The third one would be pi over 4. The fourth one would be pi over 3. And you should remember that from when we talked about the unit circle. It keeps going in intervals in that manner. If we wanted to figure out where negative pi over 3 is, we'd go back, pi over 6, pi over 4, negative pi over 3. And when we did the unit circle and we did all of the angles in order, we would have also given that a positive angle, but since we have negative pi over 3, that's why we're labeling it that way right now. And then if we start at our origin O, we want to go out 3 from there to figure out our distance. So we're out 1, 2, 3, and draw your point, and that's your answer, is that point right there. Also, you want to find 2 other points that would describe, or 2 other coordinates that would describe the same point. So one of those would be like 3, because we're talking about this line here that's this same distance 3 out from the center. And if we picked another name for negative pi over 3, one we could pick might be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 is that same angle. And if you can find your unit circle, that might help you to do that. So that would be another place where these 2 are the same angle, or the same point. And I could also pick one that had a negative radius of negative 3 if I find something on this same line but in the opposite direction. So what I mean by that is, for here you would do pi over 3 and 2 pi over 3. That would be your angle. And you would go out to 3 here, 1, 2, 3, and then reflect it back over. That's what that negative radius does. It reflects it back over to the opposite side. So from quadrant 2, it would go to 4, from quadrant 1, 3, and vice versa. And that would be your answer, your point and your 2 other points that give you the same dot. Okay, example number 2 is 2 and pi over 6. So if we label pi over 6, that would be right here. 2 out would be right here. That's our dot. And if we wanted to label that again to get 2 different points, we would maybe go around 360 degrees, or 2 pi if we were talking about radians, and do 2, and then pi over 6 plus 2 pi would be 13 pi over 6. And if we wanted to do one that was negative, we could do negative 2 and go around by pi. So this would be 6 pi over 6, 7 pi over 6. And negative 2 would get me back to this point here. The last example, 3, is the point 2 and negative pi over 6. And so again, we want to go in the negative direction this way. This is negative pi over 6. And 2 would be right here. 2 angles, or 2 points that would be the same, would be, if I came around by 2 pi, this would be 11 pi over 6. and 2. Or for a -1, I could do -2 and 5 pi over 6. Let me also mention that if you are not looking in radians and you are doing angles, to get one that would be a opposite radius, so if it was positive you'd make it negative, or if it was negative you'd make it positive, you would add 90 degrees, or to get all the way around and keep the same radius you would add 360 degrees or subtract. And then also remember when we talked about the unit circle, we'd go from 0 to pi to 2 pi. At pi that number is 3.14 and the number at 2 pi is 6.28. So if you had something in between that, you would just kind of guesstimate where that would be. Don't worry about that being on a specific line. And that's it for today's lesson.